Let's talk about some of the ways that you can debug Elastic MapReduce jobs. One of the key things is to use support for having a persistent cluster, a cluster that you start up without actually running any job flows, and then you add steps to it, and you can keep doing that until you get everything right, and then you can terminate the cluster. And what this does is it avoids that problem of, you fire up your job and you've got some parameter name wrong, and it terminates, but you had to wait for the job to start, your cluster to get configured and running, and you paid for an hour's worth of time on all those servers when the job failed in 10 seconds. So the same thing is definitely true when you're debugging your Hive scripts, where you want to be able to set up the cluster, log into the master on that cluster, and then sit there trying Hive commands until you get them right. Now, in order for this to work, you can only do it really with command line tools, and for interactive Hive sessions you have to be able to log into the master, which means you're using SSH. So how do you do this? Well, from the command line, essentially you use the Elastic MapReduce command and you create your cluster and you specify the --alive parameter, which means I'm starting it up without any steps. You sit there monitoring it until the cluster actually is ready. And at that point then you can add a step. You can add a job flows step and it'll start running, and then you can watch it again using the Elastic MapReduce command to list active jobs. And then when it's done, you can add another step, or you can terminate the cluster. And definitely you want to remember to terminate the cluster, because there's nothing quite so depressing as one morning checking the status of your AWS account and realizing that you had a cluster running for the past week because you forgot to terminate it. So let's go give that a try. So here I am at the command line, and I can check to see if I have any current jobs running, and I don't. Okay, here we are in the terminal window, and now what I'm going to do is use the Elastic MapReduce command line tool to create a cluster which is not running any steps. It's got this --alive parameter in there. It's a cluster of 3 M1 larges. And right away it tells me that it created this job flow J- and a series of letters and numbers. So at this point, what I can do is watch it, and I only want to list the active ones, otherwise I'll get jobs that I've previously run. And here it'll show me that this job is currently starting. So what I'll need to do is every so often check it, and after a couple minutes my cluster will be set up and I'll be ready to go. So now if I list active jobs again, you'll see that the state is set to waiting, which means it's waiting for me to submit a flow. So I can add that step, and I'm pasting in the command here. You can see that I'm specifying right here the same job ID that was returned from the list of active job flows. I'm specifying a jar, and this is a jar that I've already uploaded to S3. I had a note in this case, I wind up having to use the S3N protocol versus when I was setting this up with the AWS Management Console. I didn't include any of this. It was just this piece right here for the path to the job jar. And then I'm specifying all the arguments. And here I'm using the -args parameter. I can also do individual -arg and list each one separately. But here I'm putting them all together, which means they need to be comma separated. So I've got an input file, which is the directory of these XML files, and I've got an output directory where I want the results to go. And then I've got one extra parameter that I'm adding here that we're going to use later, which is --enable debugging. And what that does is sets up extra debugging state that's useful for jobs. So in this case now, if I once again list, it shows that there's two things going on here. It actually added two steps. One is the step to add the additional debugging information from this --enable debugging parameter. And then once that's done, the next step is going to be the actual job, which is pending currently. And after about a minute, you can see that it completed setting up the Hadoop debugging, and now it's actually running the job jar. We're not actually going to terminate this right now, because we're going to take a look at this debugging information and do a few other things with the job as it runs, and then at the end we'll terminate it. Elastic MapReduce has some additional debugging support that you can enable both from the AWS Management Console. So when you're defining a job flow, there's an enable debugging option that you can set to yes in the advanced options panel. And also when you're using the Elastic MapReduce tools, there's the -- enable -debugging parameter, which I used when I was setting up the job flow that we were just trying out. What happens here is extra information about your job gets persisted in SimpleDB. And when that has been done, then you have the ability from the Elastic MapReduce console, so the AWS Management Console's Elastic MapReduce panel. So when extra information has been saved in SimpleDB, then there's a debug button that lets you look at that data using the AWS Management Console. So let's go take a look at that right now. So here I see the job that's running. And when I select this job, now you can see there's this debug button here. If I click on the debug button, what it's doing here is first it gives me some information about the different steps. So the first step was that one of setting up the debugging, and the second step is the one that's running currently. If I click on View Jobs, now it's giving me some information at the Hadoop job level. And I can say View the Tasks. And it shows me here's all the current map and reduce tasks for this job that it knows about. And it shows which ones are running, which ones are completed. If I look at this particular map here, it'll just show me some additional information about this particular map task. And if this thing has completed and the logs have been uploaded to S3, then information about those logs is recorded here and I can click on them. All right, so what it's doing here is it's letting me drill into the job details, and I can do it to some extent while the job's running, but more importantly, after the job's done, I can also poke around. Whereas normally, say with some cluster that's running, once it's terminated, what I've got are the logs that have been copied up to S3, but the actual details of maps and tasks are gone. Now sometimes the AWS Management Console and the command line tool aren't sufficient. You actually need to be able to get onto the actual servers that are part of your cluster. So to do that, you've got to use SSH. And in order to SSH onto the server, you need that private key file, the PEM file, that you downloaded when you created it using the AWS Management Console. A note about this is that a common problem, you download the file, and the file permissions or privileges are too open. It means too many people who are not you can actually access that file, and so if you try and use it, SSH will complain. So you need to start doing some command line fun like chmod 600 on that file to restrict it to only you. And now when you're using SSH on a Mac or a Linux box, you're going to be using the SSH client in the terminal window, or typically on Windows you're using PuTTY. The nice thing about this is I can SSH onto, say, the master or onto slaves, and I can be immediately looking at the log files. I don't have to wait for my job to terminate and then Elastic MapReduce to copy those files into S3. And there's also this kind of interesting Linux command line browser that is provided for you, which can occasionally be useful. So let's go take a look at that job that's running currently. So a couple key things here. I've got right here the public DNS for the master. So I'm going to copy that. I also, in this directory, have my .pem file. And you can see that I'm the only one that has any access rights to this file, which means that I can say SSH, and I can do -i, AWS test pem, and I need to log in as the Hadoop user, so Hadoop @ and then the DNS name of the master. It's going to ask me if I want to add this to my list of known hosts, and I do. And now I'm into the box. As I mentioned, there's kind of this interesting thing where I can use this links command line browser here, and it gives me this very interesting display, and I can use the arrow keys to tab around and the return key to essentially click on things. And it'll actually show me details of the job as if I was using a regular browser user interface. But let's face it, this is not normal. And so we're going to show you also how to use a regular web browser window for doing these same things. Now at this point here, it tells you that the logs are here, mount var log Hadoop. So for example, if I cd into this directory, you'll see the job tracker and name node logs showing up here, and I can actually go into the steps. And so what I'm seeing here are things that are similar to what gets copied up to S3. So if I looked at, for example, one of these job tracker, the job tracker logs, there's not a whole lot of data in there. It basically is just telling me that yes, it's started to run some tasks. But I can also drill into steps. And in here, there's two steps because remember the first step was enabling debugging and the second step was the actual job that I ran. So I'm going to cd into directory 2. And here, for example, you'll see syslog. And syslog has information about that the Hadoop tasks are outputting. And I've also got standard out, which is where my logging is going. So it shows that right now this is some output that my job, my Wikipedia Ngrams job, is emitting about the parameters for this job. So again, the key thing is I don't have to wait for the job to finish and these logs to get copied up to S3. I can SSH onto the master and check them immediately. This is also what I'd need to do if I wanted to use Hive and do interactive debugging. Now let's say you need to actually SSH onto the slaves. Right? You want to take a look at some of the logs there, or you want to monitor the load on the slaves. So the problem here is you can SSH on the master, but to go from the master to the slaves, you'll need to have that same private key file, the PEM file, on the master. So the first thing you wind up having to do is to copy it onto the master, then log in the master, figure out the names of your slaves, and then SSH onto those slaves. So let's give that a try. So I'm going to exit from here. And as I said, first thing I've got to do is I've got to do an SCP, secure copy, and I have to specify the PEM file so I can do the copy. And then the thing that I want to copy up there is the same PEM file itself to Hadoop at, and then I need to get that public DNS address. And I'm going to put it into my home directory. So it's copied it up. So now I'll SSH back onto the master. And you can see that the file's there. So now I have to actually find out the names of the slaves. So one of the things I can do here is I can run the Hadoop DFS admin command, which is going to list all of the slaves that are also part of, that are serving up disk blocks that are part of the data node set. And I can say -report. And what that's going to do is list them here. And the key here is that it's showing me these internal IP addresses, which is what I actually need to use. So now I can say SSH, and again I specify the name of the PEM file, and again I have to use the Hadoop user, and I'm using an internal IP address, and so now I'm on the slave. And so here, same as before, the logs are in mount var log Hadoop, and here you'll see the data node logs and the task tracker logs, and then also the user logs, which is a directory that if I cd into the user logs, I'll have one subdirectory for every job being run. So here's that first job. And in here then, you'll see that we have these different map tasks and their log files. So when I'm done on the slave, I can exit, I'm back to the master, and then from here, I can exit once more and get back to my local terminal window. Sometimes when you have a problem with your jobs, it actually doesn't generate log output. So for example, if I specify the wrong location for the job jar, then I'm not going to get any log output because my job's not actually going to run. So when that happens, then what I need to do is actually look at details of the job flow itself. And there's two ways to do that. In the AWS console, if I got a list of jobs and I click on that job, then what you'd see here is, the last state change reason, and the state change was that the job failed, it would say that this jar doesn't exist. Or using the command line tool, if I do a -- to scribe and I give a -j in the job number, then you'll see the similar kinds of information being displayed there. Finally, there's the Hadoop GUI. Right? The issue, as I explained in a previous module, is that I can't directly use the Hadoop GUI because access to these ports on the master are blocked. And they're blocked because of this default security group. And internally, slaves use internal IP addresses. So at the very minimum, I've got to set up a proxy server. So setting up a proxy server means using the SSH command with a -i to the PEM file, and then I do -uppercase and uppercase D and what port I'm proxying, and then Hadoop at and the public DNS of the master. Once you do that, then inside of the Firefox browser, if you've got Foxy Proxy installed and configured properly, it will allow me to have those addresses be proxied through the master using SSH, and so everybody's happy. So the job trackers on this the master public DNS on port 9100, and the name node is on the master public DNS on port 9109. Now, there is another approach to this problem where you don't have to actually run a proxy, and what you can do is, using the AWS Management Console, you can edit your security group. So there's two special security groups. One's called the Elastic MapReduce -master, and the other is the Elastic MapReduce -slave. And what you could do is say, I'm going to allow all incoming access from my local computer's IP address, or you could open it up to the world. And once you've done that, then you're able to use the Hadoop GUI without having to fire up a proxy. However, you are opening up at least a view to your jobs to anybody who happens to be randomly sniffing around and finding open ports on random EC2 servers, which isn't too likely, so I often do this, but up to you whether you want to do it or not. So let's go take a look at the job that's running currently using the proxy. Back over here, you can see that last thing I'd done is I'd exited from the master, from SSHing onto the master, which means I've got right here that public DNS address, or I could do Elastic MapReduce --list --active, and it'll show me that this job is still running, and there's that public DNS for the master. So over here, what I can do is I can SSH I give it the path to my private key, -ND. I'm going to use, in my case, port 46s, and then Hadoop at, and this address here. And now that's fired up a proxy server. So what that means is I can go over to my web browser, and I can say, you know what, that same address, port 9100, let's take a look. Sure enough, I get the Hadoop GUI for looking at the job. I can drill in here, take a look at the status of this job that's running. I can also say, let's look at the name node in case I wanted to browse the file system. So I'm just demonstrating here that all the usual stuff works for the Hadoop GUI. And the key, though, is that I've got that proxy server running.